So how does the PVpredict system work? We start with the data stream from the PV inverter. We require only the data from the inverter. We need not know anything about the system at all. We do not have to know the system size. We do not have to know anything about the modules, or their inclination, or their azimuth, or the inverter. All we require is the data stream from the PV inverter. Next, we take the GIS location for the purpose of allocating a weather server. We put these two parameters into our machine learning technology, and then we calculate the next day's hourly generation for each individual system's state of health and for the DSO voltage control DERMS. We aggregate a multitude of diverse systems into a single virtual PV power plant for the TSO to reduce spinning reserve and for energy traders. In Europe, small residential and commercial systems comprise 53% of installed capacity in 2016. In California, the numbers were similar. In Australia, this was the case for over 1.6 million systems. These systems usually do not have monitoring and certainly no sensors. The monthly electric bill is often the only interface these people have with their system. This is no way to run a power station or to pay back the system capex and schedule. Our solution informs the system owner as to their system health within 12 hours of each day's end. Energy traders in Europe include utility-grade PV systems in their portfolio. The current prediction methodologies offer an accuracy of 70 to 80%. Our accuracy was 80 to 90%, and we are now achieving 95%. The difference between next-day market pricing and spot market pricing is a factor of about 3. After our first round of development ending 2014, we were already 15% better than commercial services serving the European trading markets. Blockchain technology has brought us to the cusp of peer-to-peer trading. We are working with one such venture as the production validator. Inverter manufacturers and monitoring service providers can offer little to small system owners other than inverter comparison or perhaps a performance ratio if irradiation sensors exist. PVpredict compares the PV system to its own potential. PV fleet owners and maintainers have to ascertain the health of thousands, even 10,000s of systems every day. How they do this effectively is anyone's guess, but from what I understand, the monitoring is far from close. Our services software sends a single file to the company's CRM with the health parameters for each system, based both on the potential from the weather as well as other traditional matrices. And of course, to help the small system owner to realize their business plan and to ensure availability. As per GTM, the age of the DERMS, or Distributed Energy Resource Management System, is thought to be worth $110 million by this year, 2018. We are in the middle of 2 pilot projects, one in a kibbutz in Israel, where our software will aid in managing the voltage levels in the low-voltage residential distribution system. And in Nicosia, Cyprus, we are working in 2 neighborhoods, one with storage and one without, to manage voltage levels and to reduce spinning reserve. Our DERMS is not demand side. In a residential system, this won't work. We are quite simply returning to the grid manager the control he lost with the advent of distributed solar energy. How do we do it? I invite you to download the report I wrote describing our technologies along with other new statistical performance monitoring methods developed in Australia and at the Sandy Laboratories in North America. So let's all pull together to bring about massive PV energy generation, whether you're an energy trader, a grid manager, a solar installer, or if you manage a PV maintenance company, and certainly if you own a small system, we have a tool for you.